Of everything we have discussed. Remember, started from the birth of the beam within the X-ray tube, the anatomy of the X-ray tube, the when Photon meets the patient, and controlling the journey, prevention, and decreasing or minimizing scatter, catching the exit of the beam. Remember this, and then making sure diagnosis that factors affecting the image quality. When image lights, that's lecture 6, where we discuss look heavy paint major specific part of the body, fluoroscopy and angiography DSA. So this is going to be just a recap so they can just remember everything at once. The X-ray tube that's starting the battle of the X-ray. We have our X-ray which is coming out as a result of electron going from the cathode to the anode. The X-ray, the intensity of the X-ray, where the A mostly determine the quantity of the X-ray and noise. And then we have discussed regarding the filtration, especially low energy that will be filtrated to target to the waveform. That most of the electron energy becomes heat as they come to the target at the heat the target area. So 99% will become heat. Only 1% will becomes X-ray. Out of that 1%. And then the next part of the lecture we discussed regarding when the X-ray comes out of the tube and then it emits matter. So what we have in the photon emit matter, and this we've discussed. We have got X-ray coming, the instant beam to the patient. So many things happens depending mostly on the AD, atomic number, density, and the energy as well. As the energy increases, the Compton mostly overtake or predominate in high energy, whereas photoelectric become more beta in low energy. And as a photoelectric, we have said we've got transformation, the instant beam which passes through the patient that will take the patient of the image quality, and the quality mainly comes from the Compton's quality. Also, linear attenuation coefficient mu is inverse relation or related to the half value layer, and linear attenuation coefficient equals atomic number density of what lecture 3. In lecture 3, we mentioned regarding the like controlling the journey of the beam. So we got our remnant beam going out, coming out of the patient, and the beam, which is the remnant, does not undergoes anything, neither motion or scattering, so directly transmitted. This is a remnant beam that is going to contribute to the image formation. So that image must to help get decreasing or minimizing blurring and and sharpness. So these are all part of lecture 30. And also remember, grid we have mentioned that grid will increase dose to the patient, whereas air gap increase the air gap will be lesser. So in the lecture 4, we discussed regarding catching the edge of the beam, like when the beam reached detector level. So at the detector level, what's happening? Like, two types of detector go CR computerized and digital one. For the CR, mostly the other remnant X-ray comes is going to hit into light first before before getting converted into the charges. So we get scintillator, which mostly forms from amorphous silicon. Remember, we have amorphous selenium indirect. In indirect, the food diet is amorphous silicon. In the direct, so now comes to lecture 5. Making image of diagnostic. We discussed regarding the quality factors affecting image quality. Object versus detector, displayed contrast, signal to noise ratio, contrast noise ratio, magnification, difference between magnification and digital zooming, resolution versus noise. Lecture 6 mentioned regarding when image lights artifacts. What are the distortion, artifact exposure, over and underexposure, does creep, especially in digital, whether the image is overexposed. And then come to lecture 7, mammography. The most important, the mammo is you understand the target field base and denser one we prepare using higher ones, the upper limits are around 35 kbp. Importantly, another thing very critical is MGD, main glandular dose, is more relevant to the glandular tissue of the skin. So mostly the MGD is more relevant. We have discussed that also into detail while we mentioned using either intensifier, image intensifier, II, or using flat panel detector. And the smoother motion will be with the more frame and the higher the dose. So the higher the motion, the better the motion, and the more the frame per second, the more the dose. Also, patient is the main source of scatter to the staff. That's why we are using under the couch source. And then we are measuring the cumulative dose in fluoroscopy. Remember also the DSA, we are just using photoelectric impact or implication on the X-ray image. So we capture an image, mask image with the out contrast, the pre-contrast image, then we inject contrast iodine, then we subtract the mask image from the contrast. So it will remain only the contrast vessel. So this is important. But mostly now we are using MRA, MRI angiography, or using CT angiography and others. So these are all discussed in our 8 serial lectures regarding the X-ray. So if you have any problem, go back to specific lecture, watch it. Remember, we mentioned that we started with the tube spectrum, then the patient, remnant beam that are coming out, taking the information from the patient, and then detected or captured by the detector image formation, or you optimize the image regarding the quality factors affecting the and the power of safety. So the safety is going to be discussed under radio protection. So follow RadSound for more videos. And remember, we have our channel or our site where you can have your mock exam for physics at physics.radiologysound.com. So you have access to free access to many study material, many things which is going to help you to exam. And into these 20 high-yield traps, they're all within our website, physics.radiologysound.com. Read through them, understand. Can you understand the traps? They say they are saying like collimation reduces radiated volume and scatter protection. True, false. True or false? True, because it reduces radiated volume. Then saying last email hold your hot husband and in the first seat. See you in the next section, which is going to be say tape.